That's true. I'm being recorded. Let me see. Let me see. Pause. All right. So Hannah, you're talking about, oh, it's the iTunes problem. Yeah, it is the uniform. Get back up here. Right, let me see. Where's my chat? My chat is gone. All right, I'm not gonna keep sharing this, but let me just, so we're talking about this problem right here, the iTunes problem, uniformly distributed from 2 to 3.5. I tell you what, Hannah, I know that is going to be a question everybody has, but if you did part E, did we already talk about this problem? If you got part D and E right, in fact, you already got part of F done, Hannah. The interquartile range goes from Q1, which is what you found in part E, to Q3. What percentage is below Q3? Because what does Q3 mean? Anybody? So let me find out for sure. Hannah, were you able to do part E? I don't know. It sounds familiar. So if you're able to do part E, you've already calculated the new standard deviation, you've got the mean, and you figured out the z-score because you know that Q1 has 25% below it, so you're able to find the z-score. All that must be true if you're able to do part E. Part F, one part of it is part E, because the interquartile range goes from Q1 to Q3. So you just got to figure out what Q3 is and what percentage is below Q3. What's the definition of Q3? Definition of Q3. Q3. What does Q3 mean? I got this song stuck in my brain. Ian? No? Does anybody know what Q3 means? It's kind of weird. You have to know what Q1 means if you did 65E. You just have to. Otherwise, I'm not sure how you did that. I'm not sure. I'm not sure what's happening. All right. I can see which markers are alive. So this problem happens to be normal, so I'm drawing a normal curve. Q1 would be the one that's got 25% below it. Yes? So what's Q3? What's Q3? Anybody? What the hell's Q3? Why am I putting it over there? What's Q3? Yes.
75.
Yes. So 0.75, you can find the z-score. You can make that into an x score the same way you did with part E. This is number 65F, by the way, guys. Does that make sense? I mean, that's, if you did part E, you've already got half of part F done because the IQR is from Q1 to Q3. So all you got to do now is figure out what Q3 is, and then you're done. You're done. I think if I remember correctly, I don't know if you're looking to check your work with the solutions. They definitely screwed up on this one, on E and F, I think. So just do the right work. Forget about the book. It makes mistakes. Poor little thing. It's free, but you know. All right. So let me know if you have any other questions, guys, before we start officially at 9. Oh, somebody else is here. Doop. Oh, man. Oh, I sit on my ass a lot more nowadays. It's crazy. One thing I loved about teaching was it wasn't a desk job. And now it, kind of is. Well, it's too bad, Jeff. All right, let me see. Okay. Bum, 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 bum. Where'd you go? Get ready for an announcement.
Is there a specific page in the book you're starting on, or do you have a worksheet you uploaded?
I posted a worksheet on Canvas that we might be able to get to do some stuff. My other class, we didn't quite get to it, and I said I would post a solution video, so I'm probably going to just do that. But if you go to Canvas, there's I posted, let me make sure that I actually did that. That would be really useful, Jeff. Yes, I did. It's called Section 8.1 and 8.3 handout.
Okay.
Let me see if I can, yeah, it's right in your, should be at the top of your assignments list almost, the third one down. Or second one down. Who's here? We got Garrett and Haley. Ooh. All right, 3 more minutes.
You worked on this last class?
No, I
Okay, so this
posted it last time. Let me see. And
this is new information you're going over in class?
we started doing Section 8.1 last time. So we're just going to do some more examples from 8.1. The plan was to get to that handout and start it up, but my last class, we didn't quite get to it. So I said I would post solutions for it later. Oh, all right. I don't understand. All right, sorry. Trying to keep up with emails. All right. 2 more minutes. Bum, 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 bum.
Are you fine with the no video?
Say again?
Are you fine with the no video?
Yeah, that's fine. That's fine. On the day of the final exam, everybody has to have a video going. But other than that, no.
Okay.
Yeah. Somebody's here. Bum, bum, bum. Good morning. Let me see what we got. Almost time. Somebody constructing something? Let me see. Do, 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 do.
My Keurig.
What's up?
So that was my Keurig.
Oh, all right. It sounded like construction. Sounded like somebody was sawing something. All right. I got you. Keurigs are awesome. This is exciting. So again, if anybody has a question, we got like so many whatever seconds left. Who do I have here? Let's see. Bam. I want to show you guys some stuff. I have no idea where you guys might be getting your information about COVID-19, the coronavirus. So I kind of want to show you guys some stuff here. Hold on. Oh, somebody's here. I'm just going to open the door. Let's see. All right. So I want to show you guys a couple things real quick. This is nothing you have to do for the class. Can you guys see that?
Yeah.
Okay. So this one is an interesting website. You can see that URL up there at the top. And what it does is it estimates the amount of resources required per day. So this is for the United States, and it tells us that there's going to be a shortage of ICU beds, a shortage of regular beds. Let me see. Can I do this at the same time? Hold on, guys. Real quick, I got to let somebody, oh, somebody just came in. That's right. Open the door. Excuse my old man moment here. I got multiple displays. I've got my laptop and I got my TV. Anyway, sir. So this one's kind of cool. You can look at California, for example. You can look at other countries too, but it'll tell you when the peak should happen. Right now, they estimate the peak will happen on the 14th. That's the day that they estimate we'll need the most resources. It tells us how many deaths per day. I mean, it is kind of morbid, but that's what we're living through right now. And then the total amount of deaths over time. I always like to check out the like Georgia. That's my home state, Georgia. I'm a little embarrassed that that's my home state because they didn't do a stay-at-home order until recently. Anyway, here's the other website. Let me see if I can do this. How can I do this? Let me see. I am not sophisticated enough to do that. Hold on. Oh shit, I don't want that one. Yes, I do. There we go. All right. Here's another really good website. Let me see. Worldometers info. And it's got some stupid freaking ads over here, but oh well. It actually shows you updated every few minutes, the number of new cases, the total deaths and so forth. I know it's stuff, it's morbid, but it's a nice place to come to see real information, to really hammer it home why we have to do this shelter at home shit, right? So let's see, like right now, New York has a ton of new cases. They're already bad off. So anyway, those are just two websites that I kind of check to keep up to date with real facts about what's going on with this stuff. All right, that's enough of that. So just to remind you guys, we do have the quiz, another quiz today, because, you know, quizzes are awesome. Anybody have a question about chapter 4 and 7 specifically, because that's what the quiz is going to be on? Anybody have anything from chapter 4 and 7?
So, is binomial distribution also normal distribution?
No, definitely not. We're going to find out when a binomial is normal enough, but it's not automatically normal.
Okay.
It's sort of like if I take a sample, what's got to be true for all the sample means to be normal, n has to be bigger than 30, right? Everybody should be really cool with that. There's another test. If I have a binomial, there's a certain test it's got to pass, and then I know it's normal enough. So it's not automatically normal. It's binomial until it hits a certain threshold, just like n greater than 30, right?
Okay.
Maybe
yeah.
it's uniform, and if n is greater than 30, then it becomes normal. There's a similar kind of test for binomial. It's not quite the same thing.
Okay, thank you.
Sure. Anybody else have a question? So again, if you just came in the room, chapter 4, chapter 7 quiz today, due 11:59 tonight, just like before. So any questions from, remember chapter 4, let me just do, here, let me ask myself a question. Hey, Jeff, what the hell was 4 and 7? Oh, okay. 4 was this stuff, right? Cool. XP of X stuff. Can you guys see that? I can't even see myself. Bop, there I am. All right, give me 1 second. Old man trying to use technology. There you go. All right, so now it looks like it's normal to me. Okay, remember this stuff? I'm gonna have the, okay, I'll get to you in a second, Alex. I'm gonna have the formulas on the quiz. All right, so you can't use any formula sheets you've made yourself. The formulas are on the quiz. But this was the one where the mean is the sum of xp of x and the standard deviation is this thing. I'm not gonna write it nice, just remember this, right? This does sound vaguely familiar. Chapter 4 also had binomial stuff. Right, that formula, right? And then the mean and the standard deviation, blah, 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 right? So chapter 4 was xp of x stuff and binomial stuff. Chapter 7, chapter 7 was this. It took me a long ass time to explain when and why we do this, right? And then chapter 7 problems are just like chapter 6 problems. It's just that very often I have to do this first because I took a sample. So Alex, let me see. What section, Alex? What chapter, I mean? 7-1, okay. Number 62. All right, so that's this problem here. 62. So Alex has got a question about the one about the baseballs. Get up here. Where are you going? Blah, 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 blah. So your question was about part C, right? So part C says find the 80th percentile of the distribution of the average of 49 fly balls. So they tell me, let me stop sharing. So on that one, they tell me the mean was 250 and the standard deviation, this is for just hitting baseballs. The standard deviation for a single, the average for a single hit over time would be 250 feet and the standard deviation is 50 feet. They take a sample of 49 hits, fly balls. What's the first thing I have to do before I do any probability percentage related stuff? What's the very first thing I need to do? Anybody? Anybody? What do I do when I take a sample and I ask questions about the sample mean? Yes, Alex, you have to find this. I took a sample and I'm asking about the sample mean. The little formula actually tells you when to do this. N, so I must have taken a sample. X bar, I must be talking about the sample means. The mean doesn't change, right? The mean stays the same. I don't know if you guys really understand this. If I had a room of people and I calculate the average by asking each person their age, I would get a certain average age, right? For the whole room. If I have people pair up, calculate their average age, and then I average all of those. Let me say this again. Come on, stay with me now. If I, instead of asking each person their age and averaging those, I ask each pair of people their average age, and then I average those. Won't that be the same average? I didn't change the people. We're all the same people in that room. So that's part of the whole point of chapter 7 is the mean stays the same. The average of all the averages is the frickin' average. What changes is the spread. If I take 2 people at a time, it's much less likely that their average will be really low or really high. They should be closer to the real average. Okay, maybe. So that's the whole point of this, is that the standard deviation changes, but the mean doesn't. So part C specifically, why do I know this is going to look like this now? Why do I know it's going to look like this? Yes, the sample size, where'd you go? Sample size, there it is bigger than 30. So chicken, lettuce, tomato, or central limit theorem says go for it, right? It's normally enough. And the 80th percentile is what part C wants. Where would the 80th percentile be? On the left or on the right? Left, right. Where would the 80th percentile be? B. Yes. Up here, because it's supposed to have freaking 80% below it. You've got to let, I'm not saying statistics is easy. I'm not saying that at all. You have to let certain parts of it be easy. It's got to be here. That's the only way that it could have 80 freaking percent below it. So have people just putting it wherever the hell they want to. Is that a z-score? No, it's not. I need to look up the z-score now by finding 0.8 in the middle of the chart and then looking out to see what the z-score is. And then I can use, of course, that formula to change it from a z-score back into a, what was this, a distance for a fly ball. Is that all right? Where is it? Alex, you asked that question. Is that all right? Okay. Yeah, for part A, you had to do this already for part A. You should have figured out what the new standard deviation was. Yeah, and let's be really specific. Guys, watch. Ready? You ready? Listen. I go out and I take a sample of 80 people. And it's okay if you get this wrong because this is really difficult to understand. If I take a sample of 80 people, will their ages be normally distributed? If I go out, take a sample of 80 people, will their ages be normally distributed? I like the tentative answer there. That's a very cool answer. I like that. It's a very statistical answer. I like that probably. The answer is no, not necessarily. No. 80 ages, do they have to be normally distributed? No, they could be whatever the shit. Couldn't they all be like around the same age, or some of them, it could look like this, like Florida. We went to Florida and we saw a bunch of young people and a bunch of old people. That wasn't normal, was it? So listen. What the shit is up with n greater than 30 then? Okay. If I plot individual data points, they can look like anything. Anything, I don't care. It could look like anything. So if I plot averages of samples of more than 30, they will come out looking approximately normal if I plot the averages. So a sample I take, I don't care how big it is, it's never going to be guaranteed to be normally distributed, ever. But if I took every sample of a size bigger than 30 and I plotted all their means, that's going to be approximately normal. Crazy sauce. Okay. Maybe. And let me try this. You ready? So when we do a chapter 6 problem, we have a question about one person or one thing, right? If you go to chapter 6, it's always about, we pick one thing, we talk about one person, one rent, whatever. What's the probability that that one thing is greater than this, less than this? So then I want to use a picture of individuals. Chapter 7 says, what's the probability that the sample for these 49 things or whatever is going to be greater than this? Then I need a picture of means. I need a picture of sample means. I need to compare the one I'm interested in against all the possible sample means. I know that's all really weird. I know. I'm sorry. Okay. So that's a little bit deeper. I mean, if you really understand everything I just said, you're amazing. If you don't quite, you're right in a decent place, to be honest. It's a little bit weird. I understand. Anything else that I can talk about for a while and make it sound harder? Anything? Any other questions from homework or anything? Anybody know? Okay.
I have a question.
Yes. Who's
For 7.1, can you help me on 65F?
7165? All right, good. All right, somebody was asking about this earlier, so let me see. Let me put this up on the screen. Pow! Look at Jeff using. You guys can see the book, right? Yes. All right. So let me collect a couple things, and then I'll turn off the shared screen. All right. So this one says, this is the right problem, right? Let me see. Yeah. I got a uniform curve from 2 to 3.5. 7 point, what is this? 7.1? I can't remember. Uniform curve from 2 to 3.5, right? And part C is the interesting part. Well, part C, D, E, F. C is what you asked about, is that right? Who's out there? Who had a question?
I asked for F.
F. Oh shit. Well, it doesn't even rhyme. Sorry. So F. Okay. So let me get up there. So if you were able to do the stuff before F, you're really good. I can't remember. I think we talked last time about this problem. Did we? Did we calculate the average for this problem? Do you guys remember this? I'm pretty sure we talked about this problem. I can't see the chat right now. Let me stop share. Nobody's telling me anything. All right. All right. So you can calculate the average, and what's that going to be, Jeff? 2.75. You can calculate the standard deviation. I think that comes out to be 0.433, maybe. I feel like we talked about this, but you know, could be just me remembering my other class. Yes, we did. Okay. So part F says the X bars, the interquartile range for X bar. And the interquartile range goes from Q1 to Q3. Part E, you had to calculate what Q1 was. So you've already got half of F done. First thing, remember what we had to do since I took a sample and I'm talking about sample means? That has to change. So you got to do that work, right? You got to figure out what the new standard deviation is. I don't care what the original distribution was. We took a sample and we're talking about the sample means, therefore this changes. And since the sample was more than 30, it's now normally distributed. Okay. And so the last piece of the puzzle you need for this is what is Q3? Q3 has what percentage below it? Yes, 75%. So you can figure out the z-score and then you can turn it back into, get out of there. Just make sure you use the new standard deviation here. Okay. Is that helpful? Person I can't identify?
Yeah.
Okay. So I love that problem because it starts off uniform, but the minute they take a sample of greater than 30, the means are now normally distributed. You can use the normal distribution. You can use the z-score chart. It's all there. Okay. Anything else before we get back into where we left off last time? Don't forget, everybody, I am recording these, so I am putting them up on the YouTube still. So if you miss it, or if you want to go back and rewatch something, right, feel free. Okay. All right. So not seeing any other questions. Let's get back into where we left off last time. Okay. All right, so if you weren't here last time, the video's up. Let me see if I can't give like remarkably insufficient quick summary of what we did, of where we ended up. I'm not going to redo what we did. We all should remember this formula here. Ooh, you're a good one. Oh, yeah, I can get high off that. You guys remember that formula? In fact, I just wrote it up for an earlier problem. So yes, you all remember that formula. We went through this whole thing about dolphins and how long they live around this island last time. We did. And again, if you weren't here last time for that, then go watch that. What we ended up doing was, we don't normally know this, right? In the real world, I don't normally already know what the population mean is. So I use my next best guess. Section 8.1, we kind of assume that we happen to know what this is. But since I took a sample to get X bar, I've got to change that, right? And then the whole idea is, if I take a sample mean, I already know it's probably wrong related to the real mean, the mu, right? It's probably not the same as that. So I want to improve on my estimate a little bit. So I want to go up and down a certain amount to catch so much of the data. So if I go up and down far enough to catch 90% of the data, then I'm going to be 90% confident that my interval catches the mean. So my example was, if I throw a fishing net out that's big enough to catch 90% of all the fish in this pond, first off, all the other fishermen are going to be angry at me, but oh well. How confident am I that I caught a specific fish? 90% confident. There's only 10% chance. Yeah, exactly. There's only a 10% chance I didn't catch that fish. So what is the fish we're trying to catch here is the mu. We don't know what the shit that is, but I want to give a guesstimate for what it is. I want to improve on my one thing that I can actually calculate. So what we do then is we go up and down, so many of these. So the z-score, if I want to catch more stuff, the z is going to be bigger, 90%, 95%, right? Okay, so that's nowhere near sufficient to learn from. You got to go watch that video because it took me a long time to talk about why all of this makes sense. But that is kind of like a nice refresher of what the hell we did. So let me rewrite the formula here, up here. Let me make it so that it's not. Okay. All right, so let's do an example problem of this. All right. We want to make a 99% confidence interval. So that's what it's called. They're called confidence intervals because math people are not always creative. We're like, it's an interval and I'm confident that it can. So we call it confidence intervals. Ooh. We want to make a 99% confidence interval for the true mean, length of time to do the final. You guys with me? You're going to take the final. I want to find a 99% confidence interval with the true mean length of time for all my students to take their final. Okay. So we take a sample from the past of, let's say, 73 students, and we find an average, a mean of 1.62 hours. And a standard, and I know the standard deviation of all of them is, what do you got, Jeff? 0.87 hours. All right, let me stop for a minute. So section 8.1, there are situations where I will know the population standard deviation, but I don't know what the mean is for a specific group. So I know the standard deviation of times for all stat students is 0.87. This is a sample of my stat students. So I don't know what my average is. Okay, maybe. So I already know, I really want this to make sense. We already knew this from day one. What's the only way we can get a feel for what the mean is? We take a sample and we see what its mean is. And we go, it's got to be close to that. This gives a better idea of what that close is. When I construct this interval, it gives me an idea of what that close is. So what's the only thing that I haven't told you that you need for this? Everything else we can just plug and chug. There's one thing I'm missing. No, I know the mean. What are you guys talking about? Didn't I write the mean down? There it is, right there. I know the standard deviation. There it is, right there. Oh, you can't see that? Okay. That's hours, 0.87 hours. Is that right? Can you see the 7? Yeah. So I have this, don't I? I have this, it's right there. I have this, it's right there. I have this, it's right there, right? The only thing I don't know is that, but that's going to come from how confident I want to be. Now watch. If I change how far up and down I go, I catch more or less stuff. But if I change how far up and down I go, that is changing the z-score, isn't it? How far up and down from the mean is the z-score. So that's why how confident I want to be will tell me what z-score to use. So what will this look like? How do I know I can draw this? Because you've done it before, Jeff. You could do it. You drew it. Yes, because n is bigger than 30. So I know my sample means will be approximately normally distributed. I don't know why I had to do that, but there it is. If I draw in a 99% confidence interval, so what I want to do is I want to go from my guess up and down far enough to catch 99% of the stuff. Please let this make almost too much sense. The mean, the real mean is somewhere. It's somewhere. Just like that specific fish I want is somewhere. So if I catch 99% of the data points or 99% of the fish, I will be 99% confident that I caught that fish. And what's that fish I want? The real mean. I want the real mean. Please, let that make sense. So can somebody figure out what those z-scores are? What z-scores would have 99% in between them? Well, and again, so let's build up to this. What's the only area that the chart ever understands? Yes. Yes, I love it. Below, left, all that kind of shit. So if I look up 0.99, I'm screwed because that's not, chart's going to tell me something else than what I want. So what is below this one, for example? What area is below that? That's one of the z-scores I want. So what area is below that? 99% inside. What percentage is outside? 1%. So what percentage is on this side? 0.5%, which is 0.005. Be really careful, right? 0.5% is 0.005. Can you guys look that up for me and see what z-score you get? You should get something that feels very familiar. You're going to have to follow the star path. Yeah, Emily. And of course, if I have to go down that much, this is just like Emily's saying, how far up do I have to go? The same amount. It's symmetric. Boogie woogie. So do you see why this formula makes sense? The plus and minus that are in the formula are the plus and minus that I have to do visually. Okay, so let's put all this shit together. So when I put the z-score in the formula, I don't put negative because the negative's already in the formula. There's plus and minus. So just put 2.575 in. Don't freak yourself out. So it'll be x bar, give or take. All right, you're crapping out on me. Who's going to work? Come here, you. Give or take 2.575 standard deviations. 0.87 divided by the square root of n, which was 73. So could I have taught this really fast without making you go through all my explanation? Sure, I could have just said, you know, throw that shit in, get a z-score, you know. But, you know, hopefully, I don't care how you feel about it because I'm always going to explain to you what the shit everything is. But now, when you're doing a problem, even if you didn't understand any of the conceptual stuff I threw at you, this is a very nuts and bolts, throw stuff in the formula and calculate it kind of thing. I just desperately hope that more of you understand the idea. So does anybody remember what this part was called? This part right here. I would highly, yes, that was called the error, right? This piece is called the error. I would highly recommend you do that first. So this is 1.62, give or take, figure out what that is. What do you think it's going to be, Jeff? 0.26. I don't know. Let's see. Maybe I should try in the calculator. Oh, Alex, you're way too far ahead. Slow down. What is the... I don't mean that it sounds so bad. It's good if you get the right answer, but I just want to know what the error is. What did I say? I was way off. I suck. Or what did I say? Yeah, I said 0.26. All right, good. So 1.62, give or take 0.262. I like it. Let me stop for a minute. Where's 2.24 coming from? Wait a minute. That's okay, Ree. I'm sorry. Try to do it again. Let me stop right there. Anybody have a question? All I'm doing is calculating what that is. I highly recommend you do this first, and then you just have to add it to 1.62 and subtract it from 1.62. Oh, yes, it is 0.262. Right. All right. So if I do 1.62 minus this, you're gonna try to do this in your head, Jeff? Yes, I am. 1.45. 1.458. Is that what somebody said? I can't remember. 1.458? I don't know. Hold on, Malachi. We're going to get there. Am I doing that really wrong? 2.6. Oh, you want one? I got you. 1.3. You can do it, Jeff. 1.358? 1.36? So Malachi's question is a good one. You always want to round to at least the same number of decimal places this is. Let me say that again. Round to at least the same number of decimal places that this is. So 1.36 up to 1. I agree with you, 88. So that is much more useful than somebody just telling me I got a mean of 1.62. If they instead say, I'm 99% confident that 1.36 to 1.88 hours contains the real mean, that is much more useful information, right? Just to get a little too real for a second, the COVID-19, when they estimate the number of deaths, you can see the average number of deaths, but it's much more useful to know they expect from this many to this many. That gives you a much, so if they thought in a certain state there were going to be 100 deaths, but then you see it goes anywhere from 40 to 200 or something, then you're like, okay, now I get a better overall feel because the 100 is an estimate. This just tries to improve on that estimate. Okay, so we're not done with this problem yet, by the way. Oh man, here comes everybody's most favorite part. You are not done until you write the conclusion. All right. So here's the conclusion. We are farmers. No, we are 99%. Oh man, I need a good pen. Are you going to be a good pen? We are 99% confident. No, you're not. You suck. Let me try again. At the interval, 1.36 hours to 1.88 hours contains the true mean. Length of time to finish the final. Okay. We are 99% confident that the interval we made catches or contains the true population. When I say true, I mean population. Mean length of time to complete the final exam. The nice thing is, that interval is, could the average, does it, from what we have done, is there evidence that the average is less than 2 hours? From what we have done, is there evidence? Yes, there is. There's beautiful evidence. We're 99% confident that the average is in this interval that's less than 2. The whole interval is less than 2. Is it proof that the average is less than 2? Let me try to make my creepiest face. Nope. Almost anytime the word proof comes out of my mouth, you're like, that can't be, can't happen. Too bad. We can never prove shit. Oh, the true mean length of time to finish the final, right? I kind of petered out there at the end. Too bad. So it's not proof, because what is there a chance we're wrong? Can anybody tell me what is the chance that we're wrong with what we've said, with what we found? What's the chances that we're wrong? 1% chance, right? And related to the probability I'm wrong in general, that's really good. I'm happy. 1% chance I'm wrong, that's a good day. All right. So let's see. Oh, that's right. I remember why I had to cut things short, because my internet was shitting out yesterday. Crapping out, shitting out, whatever. So let's do this. Let's go ahead and take a look at, we can get a little ahead, right now. Let me put this up. If you can, go into Canvas. I posted last week, what do you call it? You can come up with a word. A handout. There it is. I posted a handout. Let me make sure I'm not already in there. I am. I will figure this out. Yay, okay. Let me get there. Here it is. All right, let me come back. Where are you at? There you are. Let me share this. Kabam. All right, so section 8183 handout. Let's see if it will open. Oh shit, which means, let me see if the shared screen goes with this. Yay. All right. You guys see that? For some reason, I seem to be on a dolphin kick with all this stuff. So what I try to do on this handout is to really step you through all the parts that you have to do for a problem, right? You have to identify all these things. You have to find out what the z-score is, depending on how confident I want to be, all that kind of business, right? So what I'm going to do is, I told my other class, we didn't even have a chance to look at this in the other class because my internet was really messing up. I'm going to post a solution video for this handout. You guys should try it out. Just do the 8-1 side. There's a other side about 8-3. So we haven't talked about 8-3 yet. I do want to talk about a couple things here. Without doing any work, we can actually answer part B, the first part of part B. If I make a 95% confidence interval, and then I make a 90% confidence interval, which one will be bigger? Let me stop sharing here. So if I make a 90% confidence interval and then I make a 95% confidence interval, which one has to be bigger? Remember, what's the whole reason that I am a certain level of confident is because I catch that much stuff. So how much stuff does a 90% interval have to catch? 90%. What about a 95%? How much stuff does it have to catch? 95%. Will it get smaller or bigger? It's going to get bigger. Yeah. In fact, here. Let's do something that will help you on that handout. Can somebody please, can all of you, as I talk, can all of you please figure out what the z-scores would be for a 95% and a 90% confidence interval? Just take a minute. Don't write it in chat. Just figure out what those are. And maybe this time I'll remember to show you the shortcut. We'll see. But for right now, do it the long way. Okay. All right, wait a minute. Okay, guys. Anybody got the 95% confidence interval? What would the z-scores be? So to do that, you got to realize that there's 2.5%. Oh, you're a good one. 2.5% there, right? Because there's 5% outside, so there's 2.5% that side. Yes. So you should find negative 196, so then that side's got to be positive 196. For a 90% confidence interval, this one's going to be very familiar to us. I have to realize there's 5% down there, right? 10% outside, so 5% on one side. Yes, so then you should get the asterisk, and you get that. Now watch this. Make sure you can do that. Yeah, look at Malachi go. So if you look at the positive z-score side, look at the bottom, what is that? The bottom right-hand side. Do you see where it says common critical values? Look at the confidence level of 0.9. Holy shit. Look at the confidence level of 0.95. Holy shit. And then 0.99. That's the one we just did a minute ago, right? 2.575. That's what I call the little baby chart. Now, you guys know me. You know me. So you know I'm not going to ask you, I will ask you some questions about those, but then I'm going to ask you to make a 96% confidence interval or an 87% confidence interval, whatever the hell I feel like asking you, because you have to still be able to find them the old-fashioned way, which is in the body there, right? But what's really nice is they put the most commonly used ones in the little bottom corner because they're the most commonly used ones. Might as well do that. All right. So, let's see. Yeah, this is about as long as my class was yesterday because my internet went freaky. So I don't mind ending early today. I'm sure you guys don't mind either. So I'm going to post the solution video for that one side of the handout. It's called the Section 8183 handout. I'll post that later today for all my stats classes. Right after this lecture, I'm going to go make the quiz 5 active. You guys should go get that and do it so you're not up at 11:52 p.m. working on it. Yeah, and then just, let me know if you have technical issues or something, preferably before 11 p.m. because I'm going to be out, man. I'm not having a beautiful party, drinking a whole bottle of wine until midnight. I'm just not. Let's see. Future question, will there be a formula chart for the, oh, yeah. I don't know. I haven't really thought that out. I think I want to try to, I don't know. I might either put the formulas on the final or the class before the final will do a formula sheet like we did before. I'll have to think about that. Yeah. Because the day of the final, everybody is aware, the day of the final, it's going to be on Zoom. I might have to break the class up into 2 groups. I don't know. The closer we get, I'll see how many people are still in the class because I can only manage so many to watch on my screen. Because I'm going to have you on Zoom so I can have the final maintain some integrity. Most of you guys would not cheat. Some of you would. So I want the ones that don't cheat. I don't want them to be, it's not fair if some people do. That's just not fair. So I'm going to just be watching you with my good eye and my bad eye. Cool. All right. Anything else? Any other questions, guys? No? Okay. If there's no other questions, we're all done. You can start heading out and give me just a few minutes to get the quiz active in Canvas so you can get it and start working on it. Okay. All right. All right, guys. We're going to make it through this. I'll see you on Thursday. I'll have the quizzes graded by Thursday, hopefully by tomorrow. Okay. If anybody wants to hang out for a minute, if you have a question, let me know. Okay. Looks like nobody's got a question, so I'm gonna shut things down. Is that Guy Fieri, Angel? Yeah, okay. Sorry. All right. Not seeing any questions. I'm going to go ahead and shut it down, guys. I'll see you later. Bye.